In problem number 1b, we're also finding the horizontal asymptotes. Now we have a function that's a rational function, but now we have a square root in the numerator. So there's a little bit different process that we need to do for this, and these questions can be a little bit trickier than your other horizontal asymptote problems. So what we have here is we have a rational function. Now you can see that both top and bottom are polynomials, but the top is under a root, so that kind of throws off your typical look at the degree of the numerator, look at the degree of the denominator. Can't exactly do that here. So what we need to do instead is try to figure out how we can simplify that top part so that we don't have any more square roots. So again, there's a couple different ways to do this, one of which is kind of the same thing we did in part A, where you just divide every term by a certain power of x. I'm going to do this one a slightly different and faster way. So when you're doing the limits at, remember we're doing the limit as x goes to infinity, and we're doing the limit as x goes to negative infinity. When you do limits at infinity and negative infinity and you're talking about a rational function, everything that's not the highest degree term doesn't actually affect the answer. So what I'm getting at is if we're doing the limit at infinity or negative infinity of this function, we can consider it to be equivalent for our purposes to be this function. And that would not change our answer. Again, that's only because we're doing a limit at infinity or negative infinity. Obviously, that's not true in general. But this makes our life a lot easier because now we can simplify that radical and go from there. So this here, when we take the square root of 9x to the 6th, that would be 3x cubed. But the important thing that we need to remember is that is actually an absolute value because we have the square root there. It's possible that would be positive or negative. That's going to matter when we do our limits. So this is our simplified version of this function, and now we can try to do our limits. So let's first think of the limit as x goes to positive infinity. Well, if x is going to positive infinity, then we don't need the absolute value bars here because x cubed is clearly going to be positive. Remember that if you're doing an absolute value, if the term inside is already positive, then you don't need the absolute value bars. So for this one, our function is essentially just 3x cubed over 2x cubed. The x cubes would cancel out, and we would get 3 halves. When we do the limit as x goes to negative infinity, now the absolute value bar definitely does matter because x cubed, if we're taking a negative number and cubing it, we get a negative number. And in that case, to get rid of the absolute value bar, we'd have to put a negative sign in front of what's there. So you can see almost the same, but now we have a negative sign in front. Again, the x cubes cancel, and we get negative 3 halves. So for our limit at positive infinity, we got 3 halves. Our limit at negative infinity, we got negative 3 halves. And again, those determine our two horizontal asymptotes, so your answer, our two horizontal asymptotes would be y equals 3 halves and y equals negative 3 halves. Remember that horizontal asymptotes are always horizontal lines, so they're written as y equals, and those would be your answers.
The Teaching Center, UF's Learning Resource Center.